We are all tired, so I try to make it short and soft. And the title here is very different. I mean, the title of today's lecture is very different from what we had before, but it will tie up to the first lecture. You will see how, eventually, via finiteness theorems and class field theory. So here's a program, at least the beginning of a program. We are aware of the best change theorem in L-adic cohomology or étale cohomology with torsion coefficients prime to the characteristic of the variety. So the theorem says that if A is an Henselian discrete valuation ring, which we abbreviate by DVR, with residue field K of characteristic P, and if X over A is a scheme, N prime to P, if X over A is proper, then one has best change, which means that the restriction homomorphism from the model over A, the scheme over A, to the étale cohomology with torsion coefficients of X, to the étale cohomology with torsion coefficient of the special fiber is an isomorphism. So this is a basic theorem. And the question we address is what could be, maybe this word here is a little bit too much, what could be a motivic version of the best change theorem. So the main theorem I'm going to discuss is an answer for relative zero cycle, and this is based on initial ideas of Moritz Kertz. And in the sequence, we report on this theorem here, how to formulate it and what it means, and we raise a few questions on the way. So this is a program. So let us give examples. So the first example is a very classical example. If we assume X over A is a K3 surface with algebraically closed residue field, and A high enough in such a way that the Néron-Séveri on the geometric generic fiber is defined over the field of fractions of A, then the map, the specialization homomorphism from the Néron-Séveri of the geometric fiber to the Néron-Séveri of the special fiber is an injection. And this is an injection of torsion-free lattices of possibly different Néron-Séveri ranks. For example, if we assume that X is supersingular, then certainly the rank here will be 22, and it could never be 22 in characteristic 0 due to Hodge theory, the constraint of Hodge theory. So if we translate here, this has the consequence that the composite map here, which goes from peak of the model, mod n, to peak of the generic fiber mod n. So this is a restriction, and this is surjective, because we can always extend a line bundle to a line bundle because X is regular. Maybe I forgot to say that X is regular here. So it's really a K3 surface. The special fiber is a smooth K3 surface, so it's a regular model. And then we have the specialization homomorphism to the peak of the special fiber modulo n. The composite map here is just the restriction homomorphism. Then it cannot be surjective. Now another example, which is due to Rosenschon and Srinivas. They produce examples of three-dimensional smooth projective varieties over a p-adic field, here, capital K, with the property that the Char group of codimension 2 cycles, that means 1 cycles, here is infinite modulo n. So because this one is infinite, and as we already argued earlier on, the restriction homomorphism here is surjective